Welcome to Mechanotechnics N6. Today's presentation is going to be a short one. I am just going to look at this question. It is coming from one of your past papers. It was presented to me by a student that were having trouble doing the question, and I just decided to make a video and make it clear, not just for that student, but also for everybody who might want to understand how to do these kinds of questions. So the question says, figure 1 above, okay? The figure was above the question, okay? I just had to cut it and arrange it this way so that it will fit nicely on the screen, okay? But this figure was above the question. So that's why it says figure 1 above shows a shaft that carries 4 masses in parallel planes. And the planes are plane A, plane B, plane C, and plane D, okay? You can imagine each of these masses are rotating around the shaft, okay? And so they're not rotating in the same plane, okay? Each mass has its own plane of rotation. Okay, so the shaft is here, okay? This line that you see here represents the shaft, and these masses, okay, they rotate in each of them in its own plane. Okay, so the direction of rotation is actually into the page and out of the page and into the page and out of the page. Okay, so mass A here is rotating into the page, and then when it comes down here, it comes out of the page, and then here it gets back into the page. I hope you get the picture. Okay, mass A is not rotating like this. This is not how it is rotating. Mass A is rotating into the page, and it goes inside the screen and then comes out at the bottom, and up it goes and into the screen again. I hope you get the picture. It's really important for you to be able to picture these things. Okay, so mass A, B, C, and D have their own planes of rotation. Okay, they're not rotating in the same plane. And so you are also told in the question that the masses at A and D have an eccentricity of 80 millimeters. Okay, so what is referred to as the eccentricity, that is the radial distance from the shaft. Okay, so if you look at the side view of the masses, this is what you see. Okay, and the shaft is here at point O, and it goes into the page. And so now the eccentricity is the radial distance from the shaft to the center of gravity of the mass. So in this case, A and D have an eccentricity of 80 millimeters. And if you look at B and C, you will see their eccentricity is 60 millimeters. Okay, so that is the radial distance from the center of the shaft to the center of gravity of the mass. That is what is referred to as the eccentricity. And do not mix it up with the distance between the planes of rotation. Okay, so which is what you see here. These here are the distances between the planes of rotation. Okay, it's not, these here are not eccentricities. Eccentricities are the radial distance from the center of the shaft. In this case, the shaft is here at O. From the center of the shaft to the center of gravity of the mass, that radial distance, that is what we refer to as the eccentricity. Very important. So we have 80-80 and 60-60. Now the angle between the masses B and C is 100 degrees. So this is mass B. Mass B is horizontal. Okay, the radial distance, the radial line, okay, we can call it the radial line between the center of the shaft and the center of mass B is horizontal. Okay, you can see that. And now the angle between that line and that from O to C is 100 degrees. Okay, that is what they mean by this statement here. The angle between the masses B and C is 100 degrees. And that between the masses B and A, that is B here, okay, This is B and that's A. And so that angle there is 190 degrees. Very important to understand the question. And so, and they are both measured in the same direction. Okay, in this case, they are measured anti-clockwise as the picture shows. Okay, you measure them anti-clockwise like that. All right, so now the actual distance between planes A and B is 100 millimeters. Okay, plane A, okay, the plane of rotation of mass A, that is what we refer to as plane A, that plane there. The distance between that plane and this plane B here is 100 millimeters, and then between B and C is 200 millimeters, and then the total length of the shaft, or maybe let's say the distance between plane of rotation A and plane of rotation D, that one is X, okay? They didn't give a value for it. You're gonna have to find it. So question 6.1, you need to find the magnitude of the masses A and D. 6.2, you need to find the distance between planes A and D, okay? That distance X, okay, which is here. And then finally, you need to find the angular position of the mass at D, okay? In other words, they want you to find what is the angle of this, okay? For instance, the angular position of mass A is 190 degrees. The angular position of mass C is 100 degrees because we are using mass B as a reference, okay? The angles are measured from this line, the horizontal line where mass B is. Okay, that is the reference point, and we are measuring our angles anti-clockwise. And so the angle for C is 100, the angle for A is 190 degrees. Now, for question 6.3, they want you to find the angular position of the mass at D. So you will measure starting from this horizontal line here and going anti-clockwise, and you need to measure all of that angle like that. That is the angular position of the mass at D. So you need to find it. Okay, so once you understand the question, then you can now begin to solve it. It's always important to take your time to read the question at least twice to make sure that you really get the details correctly before you actually begin to write, before you actually begin to solve the question. So here what we are given, okay, we only given the mass B, okay, the mass at B and at C, okay. These are given in the question, okay. The mass at B, you can see it here, 18 kilograms. The mass C, you can see it here, 12.5 kilograms. But mass A is not given, so that's why we have a question mark, and mass D also is not given. In fact, in the first question, that is what we will have to find. Secondly, we also have the radial distances or the eccentricities for A, B, C, and D, okay? And so these are what you see here. Of course, I have changed everything to meters because we work with SI units. So the eccentricity of A, you can see it here, it's 80 millimeters, so 0.08 meters, okay? And the eccentricity of D is also 80, so 0.08. And for B and C, it's 60 millimeters or 0.06, okay? You can see that. So these are very important because in order for us to answer the first part of the question, we will need to actually complete that table where you have your forces and where you have your couples. Or if you want, you can say your moments. Okay, so that is what we're going to do next. So this is what we have so far. So now we need to complete this table. It's very important for you to know the layout of this table. It's always like this. Okay, so you need to memorize the layout of this table because this is the table that helps you solve problems on dynamic balancing. Okay, so in this case here we have four masses. And so therefore we will have 4 planes of rotation. And in this case, it's A, B, C, and D. Now you will need to write each of the masses. The mass of A, you will write it here. The mass of B, you will write it there. The mass of C and the mass of D. Then after that, you will then write the eccentricities, okay? And so the eccentricity of A, which are labeled RA, you will write it here, that of B, that of C, and that of D, okay? After you have done that, now the forces are found by multiplying the mass by the eccentricity. That is how you get the force. And in balancing, the unit we have for the force is kilogram meters. And so you will multiply then the mass by the eccentricity for each of these masses to get the force that is acting on each of those masses. And once you do that, then you will be able to fill this column, okay? Once you do that, you will be able to fill this column. And then the next thing that you need to put in the table is the distance of the planes, okay? Where are the planes located from the reference plane, okay? So if you look at this picture here, this is where you see all the planes of rotation. You see plane A, plane B, plane C, and plane D, okay? So now you can pick A as your reference plane, and then you will measure the distance of each plane from A. So the plane that you pick as a reference will therefore have a distance of 0 because it is where you are starting your calculations or where you are starting